All right, if we want to express in partial fractions the function that, the first thing we need to do is factor the bottom. So we're going to have f of x equals 5. I'm going to pull out a 2, and that's going to be x squared minus 7x plus 12. And then this is going to be x minus 4, x minus 3. So now I am going to write this as 5 over 2, x minus 4, x minus 3. So we can split this up. So we're going to have 5 over 2, x minus 4, x minus 3 can be written as a over x minus 4 plus b over x minus 3. So we'll make the same denominator. And 0x plus. So we will have ax minus 3a plus bx minus 4b over x minus 4, x minus 3. And we'll have the x coefficients equaling 0. And we will have the constant coefficients equaling that, 5 over 2. So we'll have a plus b is 0, and negative 3a minus 4b equals 5 over 2. Now, we'll do by substitution. So a is negative b. So we'll have negative 3 times negative b minus 4b equals 5 over 2. So we'll have 3b minus 4b, which is negative b, equals 5 over 2. So b equals negative 5 over 2. And then a is negative b, so negative 5 over 2 is positive 5 over 2. So this is going to be equal to 5 over 2 over x minus 4 plus a negative 5 over 2 over x minus 3. The other way we can do this, oh, by the way, yeah, the solutions seem to not be correct because that last line is not equal. When you expand it out, it ends up being, it's just over x minus 3 times x minus 4, there's no 2. So the other way to do it is if we use this cover-up method. So if we start with 5 over 2 over x minus 4, x minus 3, and this is just to check your answers, okay? In the IB, they'll often say to show it, so you have to do this whole method, but you can just kind of check it. It's a quicker way. So we have the zeros, x equals 4, x equals 3. So if we cover the x minus 4 up, and we substitute in 4, we're going to have 5 over 2 over 4 minus 3, which is 5 over 2. So this is going to be 5 over 2 over that thing we covered up. If we do, let me not cover that up. So now we're going to cover up this one, and we're going to substitute it in. So 5 over 2 over 3 minus 4, we get negative 5 over 2, and that goes over the thing we covered up. So that's just a really quick way to do it and check it. All right, so this one is going to be factored in the same way. X minus 3 over x minus 4, and I'll leave the 2 on the bottom this time. So we're going to have a over 2x minus 3. And we could even distribute that to keep it kind of together. So 2x minus 6. And then plus b over x minus 4. Make the same denominator. And distribute. So ax minus 4a plus 2bx minus 6b. And that's over our common denominator. So we have the a plus 2b is going to equal our 5, because that's the coefficient of the x. And we're going to have negative 4a minus 6b equals 1. So we can solve for a, substitute it in, and solve this one. So 21, so b is 21 over 2, which makes a 5 minus 2, 21 over 2. So that's 5 minus 21, which is negative 16. So we will have that this is negative 16 over 2x minus 6 plus 21 over 2x minus 4. So we could write this as negative 16, 2x minus 3 plus 21 over 2x minus 4. Yeah, something like this. So negative 8 over x minus 3 plus 21 over 2x minus 4. So we should definitely, for a, go from the right-hand side to the left-hand side. So expanding that, we're going to have x squared minus 2x plus 1 times x plus 1. So that's going to be x cubed plus x squared minus 2x squared minus 2x plus x plus 1. So x cubed minus x squared minus x plus 1 equals left-hand side. All right, so for B, I'm not going to do it. You can do that. So for C then, we have this. Okay, so we have x minus 1 squared, x plus 1, x minus 2 greater than or equal to 0. So if we do number line of our, when it is 0, so we're going to have negative 1 from this one, 1 from this one, and 2 from this one. And we have to check what's going on. Okay, so we're going to have negative 2, 0, 1.5, and 3. And when we substitute in negative 2, this thing's always positive, and then this will be negative, and this will be negative. So we have a positive times 2 negatives, which is a positive. At 0, we're going to have a positive, positive, negative. So this is going to be negative. At 1.5, we're going to have positive, positive, negative, which makes sense because at 1, it's an even exponent, which means it's bouncing off the x-axis, okay? And at 3, we're going to have positive, positive, positive. So when is this greater than 0? Well, it is greater than 0 here and here. So either before or equal to negative 1 or greater than or equal to 2. Okay, or x equals 1, because it can be equal to 0. All right, so that's I. Double I, we are going to have x minus 1 squared times x plus 1 over x minus 2 greater than 0. So we're going to have zeros at 1. So wait, negative 1. So these are all open holes because they can't be equal to 0. And then 1, and then 2. And we need our test points. So negative 2, 0, 1.5, and 3. So at negative 2, positive times a negative over a negative, which is positive. Then 0, positive, positive over a negative. Then 1.5, positive, positive over a negative. And 3, positive, positive, positive. So this is going to be x less than negative 1 or x greater than 2. For triple I, we have x minus 1 squared, x plus 1 over x minus 2. We want it greater than or equal to 0. So this is the same thing we just had, except now our points are filled in. So we're going to have x less than or equal to negative 1, or x equals 1, or x greater than 2. It can't be equal to 2. I shouldn't have filled this one in because it's a denominator. And you can't divide by 0. All right, so for 23, I'm not going to show that in A, but in BI, we're going to have 2x minus 1 squared, x plus 1 over 2 minus x. So our zeros are 1/2, and it can be equal, negative 1, and positive 2, not equal, because it's a denominator. We need test points. So if we do this at negative 2, positive, because of squared, negative over positive. So this is negative. At 0, we've got positive, positive, positive. At 1, we have positive, 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 which makes sense because at 1/2 it's bouncing off. At 3, we have positive, positive, negative. So this is going to be x less than or equal to negative 1. No. Yes. No. So we need in between negative 1 and 1/2 because we want positive. No, and up till 2 because it's everything here except not 2. All right, so for double I, we've got 2x minus 1 squared, x plus 1 over 2 minus x less than or equal to 0. So we use the same sign diagram. It's less than or equal to 0 up until negative 1. Or x equals 1/2, or x greater than 2. All right, so in A, we can actually cross apply because it's an equation. So 2x squared minus x minus 36 equals 3x minus 6. Subtract 3x, so negative 4x, add 6, so negative 30. Factor out a 2. And it's going to be x minus 5, x plus 3. So x is 5 or x is negative 3. Now, if we want to solve the inequality, we can't cross multiply. We need to subtract 3 and make the same denominator. So that we have 2x squared minus x minus 36 minus 3x plus 6 over x minus 2 greater than or equal to 0. So 2x squared minus 4x minus 30 over x minus 2. This factors, and we already have done that up top. And now we need a number line, and we have -3, which it can be, +2, which it can't be, and +5, which it can. So we check -4, 0, 3, and 6. So -4 negative times a negative, which is a positive, over a negative, so this is negative. 0 is going to be negative times a positive over a negative, so this is positive. 3 is going to be a negative times a positive over a positive, so negative. And 6 is a positive, positive, positive. So it's greater than or equal to 0 from -3 included to 2 not included, or x greater than or equal to 5. Okay, 25, so we have f equals g. So here we can cross multiply. That's going to be x squared minus 16 equals x squared minus x minus 2. So now we'll have x equals 14 for A. For B, find the set of values. So x plus 4 over x plus 1. We're going to subtract g at x. And this needs to be less than or equal to 0. So now we have to get the same denominator. So up top we're going to have x squared minus 16 minus, careful there, x squared minus x minus 2 over x plus 1, x minus 4. Want that less than or equal to 0. So here we're going to have x squared minus x squared, negative 16 plus 2, so negative 14, and then plus x. Same denominator. Now we're going to have zeros at 14, can be, and at 4 it can't, and at -1 it can't. Test points. So when we substitute -2 in, we're going to have a negative over a negative times a negative. So that's going to be a negative here. 0 is going to be a negative over a positive times a negative. So this is positive. 5, a negative over a positive, positive. So this is a negative. And 15 is a positive, positive, positive. So it's less than or equal to 0 before -1, but not equal to -1, or in between 4 and not equal to 4, 14, equal to 14.